All right, math minions, let's wrap up our unit on vectors here. Today we're going to hit some application problems, so we're just going to put into practice the stuff we've learned. But what I want to do first is kind of recap what we've learned about vectors. So a couple things here. Again, this is kind of getting us geared up for making sure we know for our test. All right. First thing, again, you may want to have your notes out. You may want to, in fact, it's a good idea, pause the video when you need to. Take notes. This stuff is important. So as we move forward here, if you're not already in the habit after 12 weeks of doing this, take notes. Be able to look at them. Have a place where you're working stuff out. Have a calculator ready to go as I'm working through the questions here. So you're not just watching, but you're actively participating in this, even though it's a video lesson. All right. So first thing, things we need to know. What is a vector? A vector is a set of instructions. Okay, it's a set of instructions broken up into horizontal and vertical components that get us from one point to a next. Okay, it's got a horizontal component that we can write as component form. Or we can write it with i's and j's. And that is called linear combination form. Okay, horizontal comes first and then vertical. Okay. Okay. What do the bars around a vector mean? Okay. The bars around a vector means magnitude or length of a vector. Okay, how do we calculate magnitude? We use Pythagorean theorem. Okay, magnitude of a vector, we're going to use our Pythagorean theorem. Remember to use parentheses around these when you square them, especially if you're squaring negatives. Squaring negatives always come out positive. Okay, how do we calculate the horizontal component? Well, if we want the horizontal component and we have the magnitude and the angle, then we're going to use magnitude times cosine of the angle. Okay, how do we calculate the vertical component? Magnitude times sine of the angle. All right, and the lesson we just talked about yesterday would be, how do we calculate the angle? Well, if we have our two components, from components, we do tangent inverse of B over A. Again, these are all the things that we've had to do when we've dealt with vectors. Okay, so this is the stuff we need to know. This is essentially the 6 things that I'm going to test you on Friday. Okay. Okay, so let's put these into applications. In other words, applications just word problems. So I'm not going to have you do anything new. I just want to make sure we can translate from word problems to pictures and understand what the question's asking and how to answer it. All right, determine the horizontal and vertical components. We need to be thinking that finding the A and the B. Find the horizontal and vertical components in feet per second of the velocity of a baseball hit with an initial velocity of 70 feet per second at an angle of 40 degrees above the horizontal. Okay, so it's hit at an angle of 40 degrees above the horizontal at 70 feet per second. Okay, finding the horizontal and vertical components, meaning figuring out A and B. Okay, again, if we go back, how do we get the horizontal component? Magnitude times cosine of the angle. All right, horizontal. We're going to calculate the horizontal using the magnitude times cosine of the angle. So again, the magnitude is the length, that's the hypotenuse part. So this 70 is our magnitude. And then our angle is 40 degrees. And again, it's 40 degrees above. So I know it was hit upward 40 degrees above the horizontal. So I'm going to calculate 70 times cosine of 40. So if we pull up our calculator, make sure that it is in degree mode. 70 cosine of 40 degrees. Remember, we take cosine of the angle, so that's how I know it's cosine of 40 degrees, because that's our angle, 40 degrees. All right, so we get 53.6 feet per second. Okay, what about the vertical component? Again, how do we calculate the vertical component? That was one of our major questions. How do we calculate the vertical component? We use the magnitude times sine of the angle. Remember, double bars, what do the double bars mean? They mean magnitude. Find the length of it. So they have already told us the magnitude. We are going to do magnitude times sine of the angle. Again, magnitude is the length of the vector. It's the major component, especially if this would sit at 70 feet per second. That is a magnitude. Okay, 70 feet per second times sine of 40 degrees. Okay, pull up our calculator. 70 sine of 40 degrees. So 44.99, we'll just call it 45 if we're rounding to the nearest tenth. Okay, so there's our horizontal component. In terms of entering this answer in Canvas, you're not going to put the feet per second part, but it is application, so technically we should be using some units on here. Again, what this means is that even though the ball is traveling 70 feet per second at this angle, it's like it's traveling 53.6 feet per second this way, and 45 feet per second upward. Okay, that's what that means. We have broken it down into its components. Okay. All right, here's another one. A man pushes a lawnmower with a force of 50 pounds exerted at an angle of 35 degrees with the ground. Resolve the force into its components. You're going to see one like this in the assignment today. I've put a little picture on there for you. You know, when we push a lawnmower, we don't push it upward. You know, if we push it upward, it's going to tilt the lawnmower. We want it to go horizontally ultimately, but we have to exert some force, a little bit of force downward. And so that's what this is saying. When we push a lawnmower, we have to kind of push downward. The handle ends up making it so that we have to push downwards. Otherwise, we end up tipping the lawnmower up, and that doesn't do any good for us. Okay. Again, since we know that if we put this at the origin, put the tail of the vector at the origin, that's where the 35 degrees comes into play. 35 degrees with the ground horizontally. Okay. The force is being exerted on this handle, and it's 50 pounds of force. So I can see the vector magnitude is 50 pounds, and the angle that it's making is 35 degrees. Now, we should already know two things about this vector. We should already know what signs its horizontal and vertical component should have. Okay, its horizontal component is going to be positive, and its vertical component is going to be negative because this vector is going downward. Again, it's like this is going into quadrant 4, and in quadrant 4 we have positive x's or positive horizontal parts and negative y's or negative vertical parts. So if I want the horizontal again, we've got magnitude times cosine of the angle, and the vertical part is going to be magnitude times sine of the angle. Again, I'm making a big deal out of this. All this stuff is alphabetic. Okay, you've got horizontal, vertical, H and then V alphabetically. You've got an A and a B alphabetically. You've got cosine and sine alphabetically. Okay, when in doubt, use the alphabet to help you out. All right, so let's do this one. Magnitude was 50 pounds of force, but that's acting at an angle of 35 degrees. So we pull up our calculator. We do 50 cosine of 35. And we go to the nearest tenth. That's going to make this 9 round up. So we're going to call it 41 degrees, right? Tenth would be a 9, but the 9's followed by a 5. So that's actually going to make this thing round up to 41 pounds of force. Okay. Vertical part, magnitude times sine of 35 degrees. So we're going to do 50 times sine of 35 degrees. Okay, now we got 28.7. 28.7. But here's the catch. Remember what our vector looks like. Is this correct? Is this a positive component? Should the vertical component be positive? No, because this vertical part is acting downward. Okay, it's 28.7 pounds downward. So we have to physically put a negative in front. Okay? If we can see the vector, or it makes more sense that the vector is going downward, then we have to change the sign. We're not going to be in robot mode, just blindly follow what our calculator is. You have to be thinking on some of these. Does it make sense if the component stays positive, or should it be negative because of the direction the vector is going? Okay, in this case, since the vertical component is having to push downward to push this lawnmower to get it to go so it doesn't tip over, and then we end up cutting no grass, so that vertical component has to end up being downward. It's going to be more obvious in the assignment because, like I said, on this type of question, I had a picture there for you. Okay? All right, last one. Find the component form of vector that represents the velocity of an airplane traveling east and descending at a speed of 250 miles per hour at an angle of 40 degrees below the horizontal. Okay? Descending and below the horizontal means that this thing is going downward again. Okay? So it's just going to be kind of like the last one, right? There's our 40 degrees, 250 miles an hour is how fast the plane is traveling. So same thing. We want to do the horizontal as magnitude times cosine of the angle. So magnitude is 250, cosine of 40 degrees. Again, the fact that it's traveling east, right? North, south, west, east means we're going to the right. So this, if it comes out positive, we'll keep it positive. 250 cosine of 40 degrees. So 191.5 miles per hour. And then vertical B. Vertical, we're going to use sine of theta. So 250 times sine of 40 degrees. 250 times sine of 40 degrees here. And we get 160.7. Okay, but double check. Do our components make sense? Traveling east is to the right, so that is positive, so that one's good. Okay, but descending or going below the horizontal means I have a negative vertical component. I have to make it negative because it is downward. Okay, if the calculator doesn't come out negative, I make it negative because I know what the vector's doing. Okay, all right. Again, remember our recap on some of these. We didn't apply any of the finding an angle, but you will have to do that. Remember, finding an angle, use tangent inverse of B over A, and then you have to check the quadrant. Okay, in quadrant, if the vector goes into quadrant 1, your answer should be somewhere between 0 and 90 degrees. If it goes into quadrant 2, your answer should be somewhere between 90 and 180. Quadrant 3, between 180 and 270. And if the vector goes into quadrant 4, you should end up with 270 to 360 as your answer, somewhere in there. Okay. Again, come to class with questions. Let's get this stuff figured out. Let's get ready for our test on Friday.